Let's continue building our Sims-like experience with React Tree Fiber. Hello, in this second episode we will set up a grid system to position our items. We will see how to prepare our objects in Blender to be ready to use within our grid-based project. It will unlock two things: pathfinding to avoid items and go from point A to point B, and the room builder to drag and drop items and allow anyone to create its room. But before being able to do it, we have to prepare the foundations. Let's start from where we were last time. I will clone it into a new repository, but of course you can continue on your own code. Remember that there is a server folder, run yarn and yarn dev, and in a second terminal, go to the client and run yarn and yarn dev. Now we can open the URL and we have what we created last week. We will create a grid system to place our objects into the scene. I found those 4 models on Polypizza. Of course, you can use whatever you want. I choose chair, table, a small couch, and a storage. Download the GLB file for each. Now let's open our best friend Blender and create a new file. Hit A to select everything, X to delete, and OK. Now we will load our avatar to be a reference for all the sizing of the elements we want to use. So import GLB, client, public, models, and animated woman. It appears completely broken. You can go to the armature, go here and click on rest position. So we should see the avatar correctly. If we go to the right of our model, this line is 2 meters and our avatar is like 180, so it's perfect sizing. Let's move it to this collection, select hierarchy, go to collection, and it will be reference. Now let's create a new collection and name it items. Now we can import all our items. So file, import, and GLB. Select the file that you just downloaded and import GLTF. You can see that they are from different sizes, and even if we could manage them using three.js, it will be painful to do generic code. So we want to fix it before in Blender, before using it. Okay, we can hide character armature so it's not ugly. This is node. Let's rename it with the name of the model. It should be step cubby storage. Then we have a root node, but the chair is inside. So maybe we can just remove the root node. Here it's the table, we can remove the root node, and same for the couch. Now let's move them into items. Now let's prepare our grid. Go to reference, shift A, add a plane. Where is it? It's on the top here. And the dimensions, we want 10 by 10. This is the plane we created in three.js. Switch to shading. On this plane, create a new material. You can zoom out, add, and search for checker texture. Now you drag and drop the color to the base color. And the scale, we will be using 20. Now we can go to layout, press Z, and the material preview. So we can see our grid. The scale is pretty important. It defines how many divisions you will have into your grid. I choose this value, but you can choose smaller or bigger. It's up to you. Currently, 1 meter is divided into square. Now we can prepare our objects. So we have the chair. Go to the top view, drag and drop it anywhere, maybe on the top left. Scale it down. Okay, here I don't know if the position is good. Maybe I will keep it next to the character to see if it's good. And I will move the rest for the moment. Here and here. Okay, maybe it looks a bit small, but let's see how big we are. We are currently on 3 on the X and 2 on the Z. So we can scale it without impacting the number of squares it takes. Okay, now we can move it. And yeah, it seems pretty nice. Let me explain to you. Here at this couch, you can see it's going from there to there. It will take on the x-axis 3 squares and on the z-axis in three.js but y on Blender, it will take 2 squares. This is a dimension we will set into our information in three.js later. Now let's do the same for the other objects. Go to top view. The table, let's put it next to the character. Let's check if it appears natural compared to the size of our character. It seems it fits nice. If we go to top view, it's taking 3, and here it's taking 6. It looks nice. Let's see with the chair. If we put it here, so we are only taking 2 and 2. If we are positioning it, maybe the chair is a bit too big, but we can still keep it in 2 and 2, but just making it a bit smaller so it appears natural. Go back to top view, scale it a bit down, move and see if it fits nice. Okay, seems pretty good. Go to top view, and here it looks like the position of the item is wrong because the orange dot, which is the center of the object, is not placed on the floor. Let's adjust it. Let me hit escape, go with tab to edit mode, A to select everything, G, Z, and put it on top. I will go on the right, and here it's nice. Now I can go back to object mode, select it, and I just need to do like the others to scale it. So go to top view. Let's put it here. Currently it's taking 2 because it's overlapped 2 squares. It looks nice, so maybe we can make it bigger. Top, okay. So I won't scale it more so it doesn't overflow on the 4 squares of width. It looks pretty nice. I think we're good for the sizing of the items. What we need to check to be sure it's good is that the orange dot is on the floor and at the center of the object. So it really needs to be in the middle. If it's not in the middle, go to edit mode and adjust it. And if you open here the transform information, you can see we have scale it up. It's 1.087, here it's 100, and we want to apply the transformation so it's 1 by default, and we won't touch it in three.js. So for all object, click on it, object, apply scale, object, apply scale, and same for all object, apply scale, and the chair too. Apply scale. What we want is our object position to be 0 everywhere. We could apply it in three.js, but again, we don't want to touch anything. Let's move everything to 0. We can still move them later, and if we need to do any adjustment. You can also duplicate it to another collection. 0, 0. Same for the couch. This is good, and the table also to 0. If you did any rotation, you can either apply it or just keep it and it will be applied into your exported file, so it's fine. Now, select one item. Now I'm on the chair. Go to File, Export, and GLB. Go to Client, Public, Models, create a new folder, name it Items, and export with the same name it has before, so you don't lose what it was. But if you prefer another naming convention, of course, do it. So chair.glb, format glb, include only selected object, so we only export this chair and not all our scene. Inside transform, we don't need to change anything. We can go to geometry and hit compression. Now we can do export GLTF. Repeat the process for each object. Select it, file, export, GLB, name it, and see you later. Now once it's done, you should have them in models and in items. The original name had an uppercase later for chair. Okay, before doing anything fancy, let's just try to load all our items. To do that, we will create a generic component that we will name item. New file, item.jsx. We can add the terminal, zoom it, export const item, and we will return our item. Let's say for the moment it has a name. It will be the name of the GLB file. To load our model, we will do const scene is equal to use GLTF. I don't know why the autocompletion doesn't work, so let's import it. The path of the file will be models/items. We will use name.glb and we don't need true. Okay, now we will return a primitive. The object will be the scene that we just loaded and we should be fine. We can save it and try to use it. Go to experience, scroll down. Let's try to add an item with the name of chair. We can see our chair. Let's try for the others. We have chair, couch, and the storage. Couch, small, tab, cubby, storage, and table. We have all our items here in the center. It's perfect. Now, instead of having this hard written here in our code, we want it to come from the server. Same applies for the plane geometry, which is our room size. We want to have all those data from the server. Open the index file from server. And now, instead of just having characters here, we will also have a map. We will define its size. So it's an array. We will put 10 and 10. It's what we had previously. And we will add an extra parameter, which is grid division. We say that it was 2. Again, it's because for each meter that we have here, it's divided by 2. Now what we will want our map to contain is an array of items. So items, it will be an array. But what it will contain is the information of an item, but we didn't define it yet. And it will also have a grid position, so the position on our grid. It's not a three.js coordinate. We will calculate from this grid position into three.js coordinate based on the grid division here. Let's say we will have a first item position on 0 and 0 because we are only playing with x and z axis. We won't play with the y axis for the moment as it's a 2D grid. I think we will never use the height. So now we will need to have the item size so we can position it on the grid correctly. What we will do is create a dictionary of items available inside our project. So it's a dictionary. Let's say we have the table. Its name will be the name we have, so it's table with an uppercase letter. And we will add a second parameter, the size. The size is an array with the 2 coordinates. Let's go to Blender. Okay, now let's have a look on the top of our table. If we put it here, we can see the size of our table is 3 and 1, 2, 3, 4, 5, 6. So it's 3 and 6. Here, let's type 3 and 6. Now the chair. The name is chair and the size. If we take the chair here, we move it. We can see it's taking 2 square per 2 square. So it's 2 and 2. It doesn't have to fill it completely, but as soon as you're overlapping 1 square, like maybe this, it's 3. Let's set it back to 2. Okay, now the chair is 2 on 2. Let's add the couch. The name is couch small and the size for the couch is 3 per 2. Size 3 and 2. And the last item we had, step cubby storage. The name is step cubby storage and the size, let's stop with it, move it here, it's 4 by 2. 4 by 2. Now we have defined our items here. We can use those information to add the items of the map. So here grid position we set 0. We will say it's a chair. So we'll be using items.chair. So what we will get inside this object is the name chair and size 2 and grid position 0, 0. Okay, so now we have our map information. We can go into our hello method when we join the server and we can add extra parameters. Let's return the map. We can return, for example, all the characters, even if we have them later. We can add the user ID. So ID will be socket.id. So now we will know who we are. And also for when we will want to create our room builder, let's add the items. So we know all items available to use. Nice, our server is almost ready. But if we don't want to touch it anymore, what we can do is when we generate the random position, instead of using the hard-coded 3, we can use the size of the map. So it's map.size of 0, and here map.size of 1. Now we can be anywhere when we join the server based on the map size. Later, we will need to add a check that we are not on an item of the map based on the size and all the items inside the map. Okay, so for today, the server should be ready. Just check that it restarted and it's working, so it's nice, we can hide it. Go back to our project and go to socket manager. We had on hello handler, now we have values. So let's log it and see if it works. Now if we reload and we look at the inspector, we have the map with the characters, so it's only me. I have my user ID, I can identify who am I, the items, and the information of the map. Going back to our socket manager, we will continue to use Jotai to have our store manager here. Let's create other atoms. We will need a map atom to have the information of the map. The default value will be null. Let's also do the user atom, and we won't do the items yet. We'll do it next time. Now we will use the atom, so map set map and use atom. Okay, same for the user, and inside on hello we will get those values. Set map of value dot map, set user of value dot id. I think I named it. We also get the character at this time, so we can also put it here. Now let's go back to experience, and instead of displaying those objects this way, we will try to use the atom that we created. We have map is equal to use atom of map atom from socket manager. Now what we can do is loop through our map.items. So we do .map, we have an item and the index of the item, and we will return an item. For the key, we will be using not only the index, but also the item.name and the index. And as we have multiple information, we won't just use name, we will pass the entire item. So we will need to change our item component. And we can close it. Now let's delete it here. Go to the item component, and here we only get item. And in item, we will get the name, the grid position, and the size of the item. So we destructurate item. So now we have name, we can still use it. Now if we reload, we can see the chair, but we have an issue because our character is out of the plane. It's because our plane is positioned at 0 and from -5 to 5. But our grid system, we want to start from 0 to 10. So we will need to move it. Go back to experience. Here we will remove contact shadows because it's not handy for what we will do. Go to plane geometry, and we will be using map.size for the arguments. As it's an array of x and y, it will work out of the box. But to position it at 0, 0, what we need to do is to do position x is equal to map.size of 0 by 2. And on the z-axis, it will be the same on the 1. Let's save. And now we have our character here, positioned on our plane of 10 by 10. So on the top left, it's 0. On the top right, it's 10. Bottom right is 10, 10. And bottom left is 0, 10. But you can see that the chair position is incorrect because we need to position it based on the grid position and the size of the object. Let's go back to item. And here we will need to add different things. To positionate it on the grid, we will need the grid information. We get them from the map. So map is equal to use atom of map atom. If we go back to Blender and wonder how to positionate this chair on the grid system. So if we position it at 0, 0, it would be here. It's the three.js coordinate. But we have the size of the element. So what we need to do is to add the half of the width and the half of the height. So our item will be correctly positioned into our grid system. By the way, the half is like half a square. So it will be here, the perfect position, because it's 2 by 2 and we add the half of it. Let's replicate it into the code. Position is equal to an array. We'll be using the size of the object. For the width, it's 0. And we will divide it by the map.grid division. And we will also divide it by 2 because we want the half of our item weight. On the y-axis, we want 0. And on the z-axis, we want to use the height. So far, if we look, our chair is correctly positioned on the case 0, 0. But now let's say we want to move the chair. We go back to the server, and instead of being at 0, 0, we want to put it at 4 and 4. Currently, there is no logic for it, so it's still at 0, 0. We go back to item. What we need to do is to simply add the grid position for the width divided by the map and the grid division. We do the same for the height with grid position of 1 divided by map.grid division. And now our chair is correctly positioned. Let's say that we want to rotate our chair from the server. We don't want to use a three.js rotation system with map.py. We will have only 4 rotation. So let's duplicate our chair. So we will have 2 chairs. The position, it will be in front of it, so maybe 6. And rotation, 1 will be 90 degree, 2 will be 180, and so on. Okay, so let's set it to 2, so they should face each other. We save and we look what we have. We can only see 1 chair, but we have our loop. It's because, like we did for the character, we need to clone the scene so it can render this mesh. Go to animated woman, take the clone code, only this because we don't need to clone the graph and we are not using the meshes. Go to item, and here instead of using the scene, we'll do a use memo and a clone of the scene. And instead of using the scene here, we will be using the clone. Now we have the 2 chairs. We need to apply the rotation. Let's add a rotation y is equal to rotation. We can destructurate it from the item because we added it in the server. And we will do rotation multiplied by math.py on 2. And we can also do, if rotation is not set, we will just do 0. Now we have our chairs facing each other, but it's a bit painful to move the camera because we are not centered anymore. Let's follow the character with the camera position. We can go to animated woman. Before the use frame, let's get our user ID. So it's user is equal to use atom of character atom. No, it's user atom, sorry. We also need in the experience for each character to pass the user ID. So it's ID is equal to character.id because we don't get the key here. Go to animated woman. Destructurate also the ID of the user. And we can do a check in the end. If the ID is equal to user.id, user, then we will get the camera from the state of the useFrame callback. State.camera.position.x is equal to grow.current.position.x plus 8 because it was our default camera settings. We added 8. Let's keep it like this. We do it on each axis, y and z. And we also need to do state.camera.lookat because currently the camera is always looking at 0. We want to look at the position of our character. Now, when we move, our camera follow our characters. The orbit control doesn't work anymore because we are currently updating the position of the camera. Works well. Now let's try to add more items to see if our item system is working. Let's say we want that chair to be 12, 10. This other chair, we will put it at 7 and 10. We will add a table that we will put before, so it will be 9 and 9. We want to rotate it. Let's also add a couch that we will put at 4 and 4, and also a step cubic storage with a grid position of 0, 0. We can also try to increase the size of the map to see if it works, so the width to 20. Now if we reload, we every time have a new position on the map. We can see it's longer. We should rotate the chairs to be in front of the table, but we have those items here. Next time we will do pathfinding to not go into the items. So let's try to do rotation to 3 and 1 here. Okay, now we have the chairs in front of the table. Thank you for watching, I hope you enjoyed this video. We can now create rooms from a simple configuration array. The next step of this project will start to become fun. We will cover both, but let me know what you want to see next week, pathfinding or room builder. Please don't forget to like and subscribe to help the channel grow. To continue practice, you can watch one of the other React 3 Fiber tutorials available here.